we have a question here. A bullet is fired from a gun at a speed of 280 meter per second in the direction 30° above horizontal. And we have to find out the maximum height attained by this bullet. So there is one way. You can just use maximum height formula, which is V naught sine theta whole square by 2g, where theta is the angle of initial velocity V naught with horizontal, which is given as 30°. So with this thing, you can directly put these values. Here V naught is nothing but 280 meter per second, of course, and theta is 30°, and we have to take g equals to 9.8 meter per square second, and this one is in meter per second. So whatever height will come, that will come in meter. So we just need to put these all values here, and we need to do calculation. So we can do this thing very easily. So this is V naught 280 into sine 30 is 0.5. So, or you can say 1 by 2 also. So we can write 1 by 2, that will be easier to calculate, and the square of this term, and then 2 into 9.8. So we have here 140 140 into 140 divided by 2 into 9.8. So now one more thing we can do here. We can just divide this thing by 7. So it will be 20, and 7, this will be 1.4. And then this 1.4, we can write it as, this is not that difficult now. So this thing from here, this is 1.4, we can write it as 14 by 10. That will be easier to calculate. So we can write, I'm writing here 140 into 10 divided by 2 into 14. 2 into 14, and then we can do this thing. Uh, and of course, there is multiplied with 20. So we can do, this is 10, and then we can do this thing here, and overall it is going to be 1000, and height. So this is in meter, 1000 meters. So this is one way we can do. But this formula comes from actually a concept where we are about to resolve this velocity vector along its horizontal component, which will be essentially V naught sine 30°. And then we can, this is a technique where we are resolving this vector, this V naught vector into vertical component, as well as we can resolve it into horizontal component, that will be V naught cos theta. This theta is 30° here. We can resolve this way, making this two-dimensional motion as a motion in one dimension. So how can we do that? Let's check. So we have to find out maximum height. That is, we have to consider its motion along vertical direction. So in vertical direction, there is acceleration due to gravity vertically downward, and the initial velocity is V naught sine 30, and then we can apply a concept. At maximum height, the final velocity should be 0. So if we are writing V to be final velocity, this should be 0. And as we know, final velocity squared equals to initial velocity squared, and minus or plus we can take accordingly based on the acceleration. So first we are writing a very general formula here, then we can go accordingly. So it will be initial velocity square into 2 into g into h. But for maximum height, this velocity will be 0, and then we have initial velocity V naught sine 30. You can see the same thing is coming up here as we have done in the previous case. So here 2g, which is 9.8, I'm taking negative because the motion is in upward direction while the acceleration is acting against the motion. So I'm taking minus 9.8 as acceleration here. So this sign is being reflected here. So 2g and maximum height. Again, we have reached the same conclusion. This will be V naught sine 30° square by 2 into 9.8, and this will give us V naught is here 280, so this will give us 1000 meter. But if you want to solve this kind of problem, motion in two dimension, it will be better to resolve that motion into two one-dimensional motion. So that will make the problem easy to perceive and easy to solve actually. So we can go for next example, and there you will get to know that resolving into one-dimensional problem will be more effective. So here a ball is projected with a velocity 10 meter per second at an angle of 60 degree with the vertical. So what is happening here? Let's say this is vertical direction, and a ball is being projected making an angle 60 degree with vertical. That is, this angle is 60 degree. So this angle is 30 degree, and this is, let's say, V naught, and V naught is 10 meter per second. So now we have to find out its speed at the highest point of its trajectory. Look what is happening here. If it is going to its highest point, at highest point, its vertical speed will be 0, and it will have only horizontal speed, that is Vx. So all we need to know about this Vx. So we can do the same thing here. We can resolve this motion. This angle is 30 degree now, and this is V naught. So if we want initial velocity along x, that is V naught x, this will be V naught cos 30 degree, and then it will be 10 cos 30. Cos 30 should be root 3 by 2. So we can write here 10 into root 3 by 2, which will be 5 into root 3. And of course, this should be in meter per second. So we have initial velocity. Now, along horizontal direction, there is no acceleration. And in uh, ideal case of projectile motion, we consider that there is no air drag also. So along horizontal direction, there is no any acceleration. That is, the velocity will remain constant. So if we are taking this argument, then we can say that at maximum height, even after reaching the maximum height, this Vx will be nothing but equal to V naught x, and this is 5 into root 3 meter per second. So this is our answer here. It will be easier to resolve the velocity components into horizontal velocity into its horizontal and vertical components, and then we can solve this kind of problem, making them one-dimensional problems. So here is one example, and we have checked one more example here, which was asked in 2023, and I think this one was asked in 2022. So that's all for this video.